You have learned the properties of moduli of complex numbers. Now let us do some problems based on the properties of moduli of complex numbers. Find modulus of 2 plus I divided by minus 1 plus 2i. Here there is a division of two complex numbers, so we can use this property. Modulus of z1 by z2 is equal to modulus of z1 divided by modulus of z2. Here modulus of the quotient is equal to quotient of the moduli. So we can apply that property here. Modulus of 2 plus I divided by minus 1 plus 2i. So it can be written like this. Modulus of 2 plus I divided by modulus of minus 1 plus 2i. Modulus of 2 plus I is square root of 2 square plus 1 square divided by modulus of this complex number, square root of minus 1 square plus 2 square. 2 square is 4 plus 1, minus 1 square is 1 plus 2 square 4. So 4 plus 1 5. So 1 plus 4 5. So square root of 5 divided by square root of 5. So answer is 1. So modulus of this complex number is 1. In this problem, we have to find the modulus of the product of three complex numbers. We can use this property. Modulus of z1 into z2 into z3 is modulus of z1 into modulus of z2 into modulus of z3. So this can be written like this. Modulus of first complex number 1 plus I conjugate, second complex number 2 plus 3i. So its modulus. Third complex number is 4i minus 3. Its modulus you have to find separately. Then modulus of the conjugate of a complex number is equal to modulus of the complex number. Modulus of z conjugate is same as modulus of z. So this can be written like this. Conjugate of 1 plus I, its modulus. So you can write it as modulus of 1 plus I, because when you take the conjugate, modulus will not change. Now modulus of this square root of 1 square plus 1 square, modulus of this is square root of 2 square plus 3 square, modulus of this is minus 3 square plus 4 square. Then this is 2, this is square root of 13, this is square root of 25. So square root of 25 is 5, then 2 into 13, 26. So this can be written square root of 26. So modulus of this is 5 into square root of 26. We have to find the modulus of I into 2 plus I cube divided by 1 plus I square. If you are first finding the cube of this, then multiplying by I, after that dividing by 1 plus I or square, it is going to be difficult. But if you are applying the properties of moduli of complex numbers, it's going to be easy. Here modulus of z1 into z2 is modulus of z1 into modulus of z2. Then here modulus of z1 by z2 is equal to modulus of z1 divided by modulus of z2. We can apply these properties here. Now modulus of this can be written as modulus of I into modulus of 2 plus I cube, that is to be divided by modulus of 1 plus I square, then modulus of I. Then here we can use this property. Modulus of z raised to n is modulus of z raised to n. So here 2 plus I cube, you take the modulus, then raised to the power 3. Similarly here modulus of 1 plus I square is same as Modulus of 1 plus I, then you square it. Then modulus of I is square root of 1 square. Here real part is 0. Now here modulus of this is square root of 2 square plus 1 square. Then it's a cube. Modulus of this is square root of 1 square plus 1 square. Now square root of 1 square is 1. Here 4 plus 1, 5. Square root of 5 cube. Square root of 5 cube. Then here 1 plus 1, 2. So it is root 2. It's a square. Square root of 5 cube can be written as root 5 into root 5 into root 5. Then root 2 into root 2. So root 5 into root 5, that is 5. Then 5 root 5 divided by root 2 into root 2, 2. So that is the modulus of this complex numbers. In this problem, 3 complex numbers are given. I, minus 2 plus I, 3. Now we have to find out which one of this complex number is farthest from the origin. Each complex number is represented by a point in the Argand diagram. Modulus of the complex number will give you the distance from the origin. Modulus of the first complex number. Modulus of first complex number z is equal to I. Modulus of I is 1. Second complex number minus 2 plus I. Its modulus is square root of minus 2 square plus 1 square, that is square root of 5. Third complex number is 3. So modulus of 3 is 3. So root 5 is greater than 1, but 3 is greater than root 5. So this is farthest from the origin. So these 3 complex numbers are represented on the Argand diagram. I is a purely imaginary number. So it is on the y-axis. It's a real number. It is on the x-axis. And minus 2 plus I is represented here. You can see it's clear from the diagram. This 3 is farthest from the origin. If Z1, Z2 and Z3 are complex numbers such that modulus of Z1 is equal to modulus of Z2 is equal to modulus of Z3 is equal to modulus of Z1 plus Z2 plus Z3 is equal to 1. You have to find the modulus of 1 by Z1 plus 1 by Z2 plus 1 by Z3. Now it is given modulus of Z1 is same as modulus of Z2 is equal to Z3. Modulus of Z3 is equal to 1. So you square this. So modulus of Z1 square is 1. Modulus square is equal to Z into Z conjugate. It's a property of the modulus. Modulus of Z square is equal to Z into Z conjugate. That property you can use here. So modulus of Z1 square is equal to 1. That implies modulus of Z1 into conjugate of Z1 is equal to 1. Similarly for Z2. Z2 into Z2 conjugate is 1. Z3 into Z3 conjugate is 1. So from this we can write conjugate of Z1 is 1 by Z1. By rearranging this you will get like this. Similarly conjugate of Z2 is 1 by Z2. Conjugate of Z3 is 1 by Z3. Our aim is to find out the modulus of this. So modulus of 1 by Z1 plus 1 by Z2 plus 1 by Z3. But 1 by Z1 we can write Z1 conjugate. Similarly 1 by Z2 we can write Z2 conjugate. Then 1 by Z3 can be written Z3 conjugate. Then you can use this property. Modulus of Z conjugate is same as modulus of Z. And this property Z1 plus Z2 conjugate is Z1 conjugate plus Z2 conjugate. Here Z1 conjugate plus Z2 conjugate plus Z3 conjugate. So you can write this like this. So conjugate of Z1 plus Z2 plus Z3. Then use this property. Modulus of Z conjugate is same as modulus of Z. So you can write like this. Then this is given. So its modulus is 1.